Here we are. So we're doing the Are You Ready? We're on page P, and I'm going to be doing the examples on graph paper. So you should read all this and go, wow, that's so interesting. And here we are with examples. That's how we're going to use our time on this video. Are you ready? Worksheet P. Now, each one of these is a little bit different. So as soon as you get one thing, we're going to go into something new on another problem. So be ready for that. Here we go. We're supposed to just find this answer. So what this means is 4 to what power is 8? And you can rewrite that in exponential form by saying 4 to the x is 8. And then we would say x equals what number? Well, it's not 2, right? And it's not 1. How should we do this? I don't think we're ready to solve for x right now. So watch, here's what we can do. Do you agree that 4 and 8 can both be written as what base? What base could both of those? So we're going to rewrite them both as a base 2. So the 4 is going to be 2 what? 2 squared, but there was already an x there. So we're going to write it like that. And then the 8 is rewritten as 2 to what power? 2 to the 3. Oh, well now we have an equation and the bases are the same. If the bases are the same, then what can you declare about their exponents? They're also the same, right? They're equal. So if 2x equals 3, what does x equal? Oops, 3 over 2. And I'm going to circle that. So 4 to the 3 halves equals 8. Awesome. Next one. What can we turn this square root? The square root is what power? That's going to be the 1/2. Everyone, you got to know that. In calculus, we go all the time. Square root of x equals x to the 1/2, and x to the 1/2 equals square root of x. We go back and forth all day long. Now, do you see, this is what I do in class usually, is the ln touching the e? Are they touching? If they're touching, then you can go hi-ya and cross them off, and guess what the answer is? It's just 1/2, okay? Huh? Why? How? Well, the power rule says what? The power rule says that this 1/2 can go down in front. So you would have 1/2 times the ln of e, and the ln of e is equal to the number 1. So you have 1/2 times 1, okay? But if I would never do all that work, I would just say, oh, ln is touching e, cross it off, and the answer is 1/2. The same thing goes with 10 and log. Are you ready for this? Guess what? If log is touching 10 and if 10 is touching log, they cancel and you get the number 4. I mean, are we on a roll or what? What does this plus sign tell us to do? We're going to multiply. So we have log of 2 times 50. What's 2 times 50? 100. Now, when you don't see a base here, it's base what? 10. So now this is saying 10 to what power equals 100? So what does log 100 equal? 2. Why? 10 to the 2 is 100. All right, what is the minus sign when we subtract 2 logs? We're going to combine it into a single log by doing what? Division. So 2 logs being subtracted turn into a single log by division. Now this one was multiplication. We just did 2 times 50 equals 100. We did that in our head. I'm going to write out 192 divided by 3. And you just keep going. Is 192 divisible by 3? It is. So we need to figure out what is that number. What is 192 divided by 3? Someone says 64. Do we agree? Okay. 4 to what power equals 64? So the answer to log base 4 of 64 is 3. This is how I see this on my paper. Do you guys see it as like a little spiral here? 4 to what power is 64? The answer is 3. All right, what should we do with this power and this root? We should rewrite it. Okay, so we're going to rewrite it as a rational power. A rational means a fraction, so if you want to say fractional power in your head, you can. So this is going to be the ln of e. Now what goes on top and what goes on the bottom? Oh, power's on the top, roots on the bottom. We're powerful people. On top. Where do roots grow? In the bottom. Power's on the top, roots on the bottom. So the power is 3 and the root is 5. If you're using fancy words like exponent and index, then you're way more fancy than me, okay? Are the ln and the e, are they touching? So what can you do? Hiya, hiya, calculus ninjas. And we have 3/5 as our answer. Well, we're doing pretty good, yeah? 5 minutes in and we already have 6 examples down. Are we ready for the next set of questions? Say the word solve, which means we have to get x by itself. Do you agree? Do we have a single logarithm already? Yes, it's already one single log. So our first step here is to rewrite without the log, okay? Or rewrite in exponential form. So to rewrite this without the log, what is our base going to be? The base is going to be what? Base 9. And what's our exponent? 9 to what power? To the 1/2 is going to equal this quadratic here. Okay? So we have 9 to the 1/2 equals x squared minus x plus 3. What is 9 to the 1/2? Remember we said 1/2 is the square root. So 9 to the 1/2 is 3. And what do we like about this? You should go, ooh, I like this right now. What do we like about this? What happens to the 3's? They cancel. You know it's a quadratic, so we know we have to set it equal to 0 to solve. So we have 0 equals this. Whenever we have a quadratic set equal to 0, we're going to try and factor. If we can't factor, we use a quadratic formula. So can we factor this? Is there a common factor? Yep. And then the 0 product property, so just a quad, you set equal to 0, and now we're going to use the 0 product property, which says x equals 0, or x minus 1 equals 0, which would mean x equals 1. So do you see, as we learned new functions, like we learned log functions, but this was a quadratic inside the log function. So that's why you spent the longest amount of time on solving linear equations and quadratic equations, so that when we stick them inside of other functions like this log, then you know how to solve those. All right, we're going to skip B for the video, but you can look it up. It's another quadratic. And let's do C here. Okay, everyone, do you guys see how there's 2 ln's? So you can't ever solve a log function or log equation with 2 of them. So your whole goal is to write as a single logarithm, and that's where those properties are important. So if we have to write it as a single ln and there's a subtraction between them, how are we going to write it as a single logarithm if it's a minus sign? We're going to divide. A quotient property, yes. So we're going to have x over x minus 1 equals 1. So that's called the quotient property of logarithms. Now what do? Anytime you get stuck, we're going to rewrite without the log. But this one had a base 9. What is our base here? Careful, because you can't see it, but it's an ln. So if it's a log and you can't see it, it's a 10. But what if it's an ln? What's the base of ln? E. Okay, ready? Here we go. We're going to rewrite. So we're going to say e. Now what's our exponent in this equation? E to the 1 equals this. E to the 1 equals x over x minus 1. All right. How do we solve this? This is solved for e, but we need to solve it for x. So what we're going to do is multiply both sides by x minus 1. To get rid of the fraction. On the left here, we're going to distribute. So we have e times x minus e times 1 equals x. Now we're trying to get x by itself, correct? Now we have x's on both sides, so back to linear math, because it's x to the 1, we need to get the x's onto one side. So why don't I leave this e to the x here, and I add this e to the right and subtract the x to the left. You guys okay with that? A little messy. Here we go. Is e by itself yet? No. What do we do with these x's? Do you see an x in both terms? Okay, so say factor. Factor. Here's what we're going to do. We're going to factor this x out, and we have e minus 1. The goal is to get x by itself. So one more step. What are we going to do to get x by itself? Divide by e minus 1. E over e minus 1. Look at what awesomely cool mathy math thing happened. Didn't we start with e equals x over x minus 1? And what did we end up with? X equals e over e minus 1. Isn't that crazy? Isn't that fun? All right, I have a few more examples, but I only have a couple minutes. These are all off the worksheet. So these are called exponential equations, and we're going to use logs to solve them. When you don't have the same base and you can't write the same base, one fun thing you can do is take the log of both sides. And the reason we do that is to bring this power down. So if you see that x up there in the exponent and you're like, what the heck? How is it up there? How do I get it down? I need to solve for x, but it's stuck in the exponent up here. The only thing that brings it down is logs. Okay? So what brings an x out of the exponent? Logs. Now, how do we get x by itself if this says x times log 5? Divide by log 5. Okay. This is your final answer. Could you plug it in the calculator and get a decimal? Yes, but we're not going to. So that's the final answer. Okay, I think we have time just for this one. And this one you'll see in calculus a lot. What will cancel the e? What's the inverse of e? The inverse of e is ln. So we're going to take the ln of both sides. Why do we take the log? Well, because it was 5 and 20. Nothing really special. So we're going to take the ln because e is special. And whatever you do to one side, you do to the other. Now the e gave me the clue to use the ln, but the point of using the ln, why are we using the ln, is to get this exponent down to ground level, okay? You cannot solve for x when it's hiding up there. And I'm down to just a few seconds. ln of e is a number and ln of 5 is a number, and we need to get x by itself. Ready? ln of 5 over, do you see this x? This is what we're isolating here. We're getting that by itself. So we're going to divide by -2 and the ln of e. So we have ln of 5 divided by -2 ln of e. We're going to skip this for the video because I'm out of time, but these examples should help you complete worksheet P in the Are You Ready?